let's play a thought experiment. Imagine you could hold all of Earth's history. Every volcanic eruption, every ice age, every mass extinction, every heartbeat of every creature that ever drew breath on this planet, and compress it into a single day. 24 hours, midnight to midnight. The Earth forms at 12 a.m. The oceans fill by 2 a.m. The first primitive life, barely more than chemical reactions with ambition, sparks into existence somewhere around 4 a.m. For the next 12 hours, 12 full hours, life on this planet is little more than slime and single-celled things drifting in shallow seas. No eyes, no movement, no hunger, just chemistry, happening very slowly, in the dark. The first complex animals don't appear until around 9 p.m. Dinosaurs arrive at 10:56 p.m. They rule the planet for what feels like an eternity to them, and in our compressed day, their entire reign lasts less than an hour. They're gone by 11:41 p.m., and then, in the final 23 minutes before midnight, mammals diversify and spread. Primates climb into trees. Something starts walking upright on the African savanna. The lineage that will eventually become us, Homo sapiens, anatomically modern humans with brains exactly like yours, appears at approximately 11:58 p.m., 1 minute and 58 seconds before midnight. Think about that number. Hold it for a moment. Now here's the part that should keep you awake at night. For the next 1 minute and 56 seconds, those humans, our ancestors, people who looked exactly like us, people with the same sized brains, the same hands, the same vocal cords, the same capacity for language and love and grief. They do almost nothing. They make stone tools, they move around, they survive, they die. Generation after generation after generation. For 1 minute and 56 seconds of our compressed day, human existence is essentially unchanged. And then, at 11:54 p.m., 6 seconds before midnight, the first cities appear. Writing is invented. Pyramids rise from the desert sand. Empires stretch across continents. Philosophy, mathematics, law, religion, science, all of it in the last 6 seconds. And in the final quarter second before midnight, we go from horse-drawn carriages to landing on the moon, from the telegraph to the smartphone, from figuring out how a steam engine works to building machines that can think. 6 seconds out of an entire day. Or, if you want to think of it in terms of actual years, anatomically modern humans have existed for roughly 250,000 years. For approximately 240,000 of those years, the pace of change was so slow, it was almost imperceptible. The same basic stone tools, generation after generation, the same small groups moving with the seasons, the same struggles, hunger, cold, predators, disease, and then, in the last 10,000 years, everything changed. Why? That is the question at the heart of this documentary. And it's not just an academic question, the kind of thing archaeologists argue about over conference room tables. It's the question that contains every other question about who we are, what we're capable of, and where we might be going. Because here's the truly disorienting thing. The people who lived in that long silence weren't primitive. They weren't less intelligent than you. They weren't missing some crucial piece of cognitive hardware. The brain you're using right now to process these words, to wonder, to doubt, to imagine, is functionally identical to the brain of a human being who lived 250,000 years ago and spent their entire life hunting antelope and making hand axes from flint. The hardware was already there, every bit of it. The capacity for mathematics, for poetry, for engineering, for philosophy. It existed in the skulls of our ancestors for thousands of generations before anyone used it to build a city or write a sentence. So why the silence? What were we waiting for? And what finally broke it? Those are the questions we're going to explore together. We're going to walk the entire arc of human history, from those desperate, brilliant survivors clinging to existence on the African savanna, through the long accumulation of skills and stories and small innovations, to the moment when everything suddenly accelerated into something no previous species had ever done. We'll see how catastrophe shaped us, how migration transformed us, how art, language, and the act of burying our dead rewired the way we think, how a few crucial inventions triggered a cascade that is still accelerating today, and where that cascade might be taking us. This is the story of the longest silence in history, and the most extraordinary explosion that followed. Let's begin. Africa, 300,000 years ago. Picture a landscape that would feel simultaneously familiar and deeply alien. Savannas stretch to the horizon, but these aren't the carefully curated grasslands of a nature documentary. These are wild, unpredictable places, swinging between lush abundance and bone-dry devastation with brutal unpredictability, often within the span of a single human lifetime. The megafauna of this world would dwarf anything alive today. Elephants 3 times the size of modern species. Giant buffalo whose hornspan is wider than a man is tall. Hippos the size of rhinos. And hunting these giants, saber-toothed cats powerful enough to take down prey that would dwarf a modern horse. Cave hyenas that could crack bone like crackers. Leopards large enough to drag a full-grown human up a tree the way a house cat carries a mouse. Somewhere in this world, small groups of your ancestors were trying very hard to stay alive. They traveled in bands of maybe 20 to 50 individuals, never more, because the landscape couldn't sustain larger concentrations. They moved constantly, following water sources, tracking seasonal migrations, remembering which plants fruited in which valleys during which months. They had fire, they had stone tools, carefully shaped hand axes, and scrapers that required genuine skill to produce. They cared for their injured and elderly, which tells us something crucial. They possessed empathy, and they understood that some members of the group had more value than a simple caloric accounting would suggest. Here is what archaeologists find both fascinating and deeply puzzling about these people. They had brains essentially identical to yours. Not smaller, not simpler, not wired differently in any fundamental way. The average cranial capacity of Homo sapiens 250,000 years ago was roughly the same as it is today. The neural architecture, the connections, the regions, the fundamental hardware of human cognition was already fully in place. Researchers have thought carefully about what this means, and the conclusion is startling. If you could somehow take an infant born in Africa 250,000 years ago and raise them in a modern family, they would learn to read. They would learn calculus. They would navigate smartphones and understand democracy and create art and fall in love and argue about politics and do every single cognitively demanding thing that modern humans do. Their brain would not be the bottleneck. The hardware was there, fully developed, ready to run any software we might throw at it. So why weren't they running it? Why were those same brains just as capable, just as complex, spending their days doing the same things, generation after generation, millennium after millennium, with almost no visible acceleration? Anthropologists have a name for this puzzle. They call it the behavioral modernity problem. You have people who are biologically modern in every meaningful sense, cognitively capable of everything we do today, but whose behavior seems frozen in time. The same basic stone tool designs appear across Africa for hundreds of thousands of years, barely modified, barely improved. The pace of innovation is so slow that by modern standards, it barely registers as innovation at all. Some researchers argue that behavioral modernity was always there, just waiting for the right conditions, that the capacity for language, art, mathematics, and complex social organization existed in dormant form long before we have evidence of it being used. Others think something specific changed in the structure of human cognition, some threshold crossed, that suddenly unlocked capabilities that had been latent. But there's a third explanation, and it's the one the evidence increasingly supports. Survival itself was consuming every single ounce of human ingenuity. Think about what it actually means to be a small band of humans in that world. You need to track game across hundreds of square miles of savanna. You need to understand the seasonal patterns of dozens of different plant species. You need to navigate territorial disputes with neighboring bands. Without triggering violence, you can't survive. You need to care for children and the elderly and the injured while also doing all of the above. You need to maintain enough genetic diversity to avoid inbreeding, which means maintaining relationships with other bands across distances that might require days of travel. You need to do all of this without writing anything down, without any technology more complex than a stone hand axe and a fire, against a backdrop of climate instability that could turn your reliable hunting ground into a desert within a generation. This wasn't a life of leisure interrupted by occasional moments of clever tool-making. This was a relentless, full-capacity cognitive effort just to keep enough people alive to perpetuate the group. And here's the cruel irony. The very intelligence that would eventually build the pyramids and write the Iliad and sequence the human genome was, for hundreds of thousands of years, almost entirely consumed by the problem of not dying today. The hardware was ready. The world just hadn't given it enough slack, enough breathing room, enough surplus, enough stability to do anything except survive. That was about to get dramatically worse before it got better. Because somewhere in the volcanically active Indonesian archipelago, a mountain was building pressure. And when it finally released that pressure, it would push the entire human species to the very edge of extinction. It would also, perhaps, be exactly the catastrophe we needed. The catastrophe that almost ended everything, and why it didn't 74,000 years ago. A mountain in what is now Indonesia did something that makes every volcanic disaster in recorded human history look like a kitchen accident. Mount Toba erupted, not the way volcanoes typically erupt, with dramatic lava flows and ash clouds that disrupt air travel for a few weeks. Toba underwent what geologists call a super eruption, a cataclysm so enormous that it ejected an estimated 2,800 cubic kilometers of material into the atmosphere. To put that in perspective, the eruption of Mount St. Helens in 1980, which killed 57 people and caused catastrophic regional damage, released about 1 cubic kilometer. Toba released 2,800 times that. The ash cloud spread across the Indian Ocean, the Arabian Sea, and much of Africa and Southeast Asia. Sulfur dioxide billowed into the stratosphere, where it combined with water vapor to form a reflective haze that blocked solar radiation on a global scale. Temperatures plummeted. In some regions, average temperatures may have dropped by 15 degrees Celsius or more. Growing seasons collapsed almost overnight. Plants died. The animals that depended on those plants starved. And the humans who depended on those animals, small bands already living on the knife's edge of survival, were pushed into territory that had never existed before. The edge of extinction. We know this not just from the geological record of Toba's ash layer, which appears in cores drilled from ocean sediments across the globe. We know it from something far more intimate and far more disturbing. Your DNA. When geneticists analyze the diversity of human genomes today, they find something unexpected. Humans are extraordinarily genetically uniform for a species our size. Chimpanzees, who number in the tens of thousands, show more genetic diversity than 8 billion Homo sapiens. This is what's called a genetic bottleneck, evidence that at some point in our past, the human population crashed catastrophically, eliminating most of the genetic variation that existed before the event. Some estimates suggest that the total number of breeding humans alive in the aftermath of Toba may have been as low as 3,000 to 10,000 individuals worldwide. Some researchers think it may have been even lower, 3,000 people. Think about what that means. Your entire species, every human being alive on Earth. Every person who would ever live from that moment forward descended from a population smaller than a modern high school. The genetic legacy of every human being who had lived in the previous hundreds of thousands of years was almost entirely erased. Entire lineages, entire branches of the human family tree, gone. Languages lost, knowledge lost. Everything that those groups had accumulated over countless generations, the hard-won understanding of which plants were edible, which animals were dangerous, which seasonal patterns governed survival in their particular landscape, gone with the people who carried it. The survivors were not necessarily the smartest or the strongest or the most innovative. They were the ones who happened to be in the right place, near enough to a reliable food source, far enough from the ash fallout, sheltered enough from the temperature drop. In the brutal arithmetic of extinction-level events, luck matters as much as skill, but they survived. And here is where the story pivots. Because the Toba bottleneck, one of the worst disasters in human history, may have also been one of the most important moments in our story. Not because catastrophe makes people stronger in some vague motivational sense, but for very specific structural reasons. When a population crashes and then rebounds, the survivors carry something precious, a filtered genetic legacy, the traits and tendencies that helped small groups maintain cohesion under extreme pressure, cooperation, flexibility, the ability to rapidly adapt social structures to new circumstances. These traits would have been disproportionately represented in any group that made it through. More than genetics, those survivors carried knowledge, not the accumulated knowledge of all the groups that had been lost. That was gone. But their own knowledge, their own hard-won strategies for endurance, and perhaps something else, what researchers sometimes call a cultural memory of vulnerability, a deep, perhaps preconscious awareness embedded in stories and rituals, in the way groups organized themselves and related to the resources around them, that the world could turn deadly without warning, and that the only real protection was the group, the people around you, the network of obligations and relationships and shared knowledge that kept everyone alive when any individual would perish alone. When the volcanic winter finally ended, when the climate began to stabilize, when plants returned, when animal populations recovered, the humans who emerged from their refuges were the same species in almost every biological sense as the ones who had entered the crisis. But something had been tested and hardened. Some quality of social cohesion, some capacity for endurance under impossible pressure, had been selected for in a way that nothing else could have managed. They came out of the darkness, and very soon they would begin to do something that no human had done clearly enough to leave a record before. They would create meaning, not just tools, not just survival strategies, meaning. The first evidence appears in a cave overlooking the Indian Ocean in what is now South Africa, and it changes everything about how we understand what we are. The birth of the inner world, Southern Africa. 77,000 years ago. The volcanic winter has lifted. The climate is slowly, tentatively warming. Your ancestors have survived the worst thing that has ever happened to a human population. They have come through the bottleneck, maintained their groups, held on to enough knowledge to feed and shelter themselves. The crisis, in the immediate sense, is over, and in a cave overlooking the Indian Ocean, a cave that will one day be called Blombos, someone picks up a piece of red ochre and begins to scratch lines into its surface, not randomly, not accidentally, deliberately, carefully, with clear intention. The result is a geometric pattern, cross-hatched lines forming a series of diamonds, repeated with a regularity that speaks of planning, of a predetermined design, of a mind that could hold an abstract image and then execute it in physical form. This object, a piece of ochre roughly the size of your palm, covered in lines that mean nothing to the naked survival calculus, has been lying in the sediments of Blombos Cave for 77,000 years. When archaeologists excavated it in 2002, they recognized it immediately for what it was: the oldest known abstract design ever created by human hands. Take a moment with that. This isn't a tool. It doesn't cut anything or scrape anything or make hunting easier. It serves no immediate survival function, none whatsoever. It is just a pattern. Lines on a rock. Someone spent time and energy creating it for reasons that had nothing to do with finding food or avoiding predators. But those lines mean something vast and profound about the nature of the mind that created them. Whoever made this engraving was thinking symbolically. They were assigning meaning to a physical object that had no intrinsic meaning. They were creating significance where the physical world offered none. They had crossed a threshold that separates a very clever animal from something qualitatively different, a being capable of living simultaneously in the physical world and in a world of their own construction. Around the same time, other people at Blombos were doing something equally extraordinary. They were drilling tiny holes in specific types of seashells and stringing them together to wear as jewelry. Not for warmth, not for protection, for appearance, for the way they communicated something about the wearer to anyone who saw them. Think about what this requires. You have to decide that a shell has value beyond its physical properties. You have to imagine how it will look worn, how it will be perceived by others, what it will signal about you. You have to collect specific shells, not just any shells, but the right ones, the ones that meet some aesthetic or social criterion you've established. You have to carefully drill holes without breaking the shell. You have to thread them in a particular order or pattern. And you have to care about all of this enough to invest the time when time was genuinely precious, when every hour spent not finding food was potentially an hour that cost you calories you couldn't afford. This is symbolic behavior, the ability to assign meaning to objects and actions that extend far beyond their immediate practical function. And it represents something that deserves to be called a cognitive revolution, even if it happened so gradually that no one living through it would have noticed the change. Because once you can think symbolically, once you can create abstract meaning and communicate it to others, the entire landscape of human possibility opens up. You can create art, you can create religion, you can create mathematics, which is, at its core, a symbolic system for representing relationships that exist only in the mind. You can imagine futures that don't exist yet and make elaborate plans to bring them into being. You can tell stories about the past and use those stories to guide decisions in the present, or to establish obligations that will be honored in the future. You can build moral frameworks, abstract rules about how people should treat each other, and enforce them socially without physical coercion. You can, in short, do almost anything that makes us human. The Blombos findings aren't isolated. Across southern and eastern Africa, archaeological sites from roughly this same period show similar evidence of symbolic thinking beginning to emerge. At Bottleneck Cave, also in South Africa, archaeologists have found carefully crafted bone tools with sophisticated shapes that required planning and technical knowledge to produce. More shell beads, these ones showing evidence of being worn regularly, the holes smoothed by friction, suggesting they were strung and carried for extended periods. And pigment, enormous quantities of pigment, red ochre, ground into powder and mixed with fat or plant resins, stored in shells and animal bones for later use. People weren't just noticing that certain rocks were an interesting color. They were actively seeking out ochre-containing rocks, sometimes traveling significant distances to obtain them, grinding them to a precise consistency, mixing them with organic binders, and storing the resulting pigment for future use. But here is where the story becomes more complicated and more human. These sparks of symbolic behavior don't appear consistently in the archaeological record. They flicker, they appear at multiple sites, and then seem to vanish. You get sophisticated toolmaking at one site dated to 90,000 years ago, and then nothing similar for another 20,000 years. Shell beads appear, disappear, and reappear again in slightly different forms thousands of years later. This pattern has generated intense debate among researchers. Some argue that these are isolated innovations, individual groups stumbling onto symbolic behavior independently, then losing it when populations crashed during climate downturns. Others insist there must have been a sustained cultural tradition, a continuous thread of sophisticated behavior that simply hasn't left consistent archaeological traces. Both might be right, and the reason is something anthropologists call the cultural ratchet problem, one of the most important and underappreciated concepts in understanding why human civilization took so long to emerge. In a large, well-connected population, innovations accumulate like a ratchet mechanism. Each generation builds on what the previous generation established. Knowledge is rarely lost entirely, because so many people carry it. But in small, isolated populations, groups of a few dozen people, separated from their nearest neighbors by hundreds of miles, the ratchet can slip backward. Knowledge gets lost, skills disappear. An elder who was the sole carrier of a particular technique dies without having transmitted it fully. Each generation has to partially reinvent what their great-grandparents knew. Your ancestors may have been caught in exactly this trap for tens of thousands of years, developing symbolic thinking, creating art and ritual, and complex social practices, then losing it all when populations crashed during climate downturns, only to redevelop similar practices again when conditions improved. An agonizing cycle of cultural birth and death repeated across millennia. Innovation that never quite accumulated fast enough, never reached quite enough people to become self-sustaining. But there's one more piece of evidence from this period that points towards something even deeper happening in the human mind. Burial. Not elaborate burial with grave goods and ritual objects, that comes later, but intentional burial, the deliberate placement of bodies in specific locations, sometimes with objects, sometimes oriented in particular directions. Border Cave has yielded what may be the oldest known burial of a human infant, carefully placed in a small grave with a perforated shell nearby. Think about what intentional burial requires. To bury someone deliberately, you need to conceive of death as something more than biological cessation. The person who was alive is now gone, but they're still important. Their body still warrants care. The act of placing them in the earth in a particular way, possibly with objects that meant something to them or to you, requires a cluster of abstract concepts that are extraordinarily sophisticated. Memory, identity, the persistence of significance after the end of function, perhaps some concept of a state of being that continues beyond death. These are not practical survival questions. These are philosophical questions, the deepest questions any mind can ask. Who are we? What happens when we die? Does anything continue? Is there meaning in existence beyond the brute fact of survival? These questions would eventually generate religion, and art, and literature, and philosophy, and science, which in a sense is just a very rigorous method for asking questions about the nature of reality. The sparks were there, flickering in the darkness of 77,000 years ago, sometimes bright, sometimes barely visible. A person scratching lines into ochre for no practical reason. Someone stringing shells to wear around their neck. A group burying their dead with care and ceremony. They were becoming something more than a clever primate optimizing for survival. They were becoming conscious of themselves, aware of their own awareness, capable of building worlds inside their heads and then reaching across time and distance to share those inner worlds with each other. And that changed everything. How we spread across the world and what we found there around 70,000 years ago, give or take, as archaeology always reminds us, something changed in the demographic patterns of our species. Human populations that had been carefully maintaining a precarious balance across Africa for tens of thousands of years began to move. Not just the usual seasonal migrations that had always characterized hunter-gatherer life. Something more fundamental. Populations pushing outward, toward edges of the continent, and then beyond, into territories that no human being had ever visited. Nobody knows exactly what triggered this expansion. The climate was improving after the Toba catastrophe. That much is clear from the geological record. East Africa was becoming wetter. Grasslands were expanding. Prey animals were recovering and multiplying. One possibility is simple population pressure. More people meant more competition for the same resources, pushing groups outward toward less contested regions. Or maybe it was curiosity, that uniquely, stubbornly, irrepressibly human compulsion to see what lies on the other side of the next ridge, to find out what that range of hills looks like up close, what those distant mountains are hiding, what lives in the forest you can see on the horizon that you've never entered. It's easy to underestimate curiosity as a force in human history. We tend to emphasize necessity, the survival pressure, the climate change, the resource competition. But humans explore even when they don't need to. They climb mountains that offer no strategic advantage. They sail into open ocean without any certainty of what lies beyond. They ask questions to which the answers have no immediate practical application. That impulse, the impulse to know, to see, to go, may be one of the deepest things about us. And 70,000 years ago, it may have been as much a driver of the Great Expansion as any resource shortage. The migration happened in waves, through multiple routes. Some groups crossed the narrow strait at the southern end of the Red Sea, possibly during a period when lower sea levels made the crossing more manageable. Others moved through the Sinai Peninsula into what is now the Middle East. These weren't mass exoduses, organized movements of thousands of people at once. Probably just small bands of a few dozen individuals, deciding that the resources looked better elsewhere, that the pressure behind them was growing, that the horizon ahead was worth investigating. The most successful route appears to have been coastal. Groups followed the shorelines of the Arabian Peninsula eastward, then along the rim of the Indian Ocean. This strategy made enormous sense. Coastlines provide reliable, diverse food sources: shellfish, fish, seabirds, marine mammals, even when inland territories are harsh and unpredictable. A group following this coastal highway could move with reasonable speed without needing to develop entirely new survival strategies for each new environment. Archaeological sites suggest that modern humans reached Southeast Asia by at least 65,000 to 70,000 years ago. By around 65,000 years ago, possibly even earlier, they had reached Australia. Australia. Think about what that means. Australia has been separated from mainland Asia by deep ocean channels for tens of millions of years. There is no land bridge, no way to reach it accidentally by following a shoreline or stumbling across a river crossing. To reach Australia, your ancestors needed boats, real, seaworthy vessels capable of carrying people, supplies, and fresh water across open stretches of ocean. They needed navigation skills, understanding of currents, of prevailing winds, of how to maintain a course across water where there are no landmarks. They needed planning, coordination, the ability to organize a group effort toward a distant, uncertain goal. This was not primitive wandering. This was sophisticated maritime technology. And as these populations of modern humans spread westward into Europe and eastward through Asia, they encountered something that should have been far more disorienting than any new landscape. They encountered other people, not other bands of Homo sapiens, other human species, Neanderthals, stocky, strong, cold-adapted humans who had been living in Europe and Western Asia for hundreds of thousands of years, were already there. They had their own tools, their own fire, their own social structures, possibly their own language, though the evidence for this remains contested. Denisovans occupied large portions of Asia, and though we know them primarily from genetic traces and a few fragmentary fossils, they too had clearly been successful enough to spread across an enormous geographic range. What happened when modern humans and these other human species met? The honest answer is that we don't know the details. We know the outcomes. Both Neanderthals and Denisovans disappear from the fossil record within a few thousand years of modern human arrival in their territories. But the events that produced those outcomes are mostly invisible to us. What we do know from the remarkable science of ancient DNA is that the meetings weren't purely hostile. Modern humans and Neanderthals interbred. The genetic evidence is clear and unambiguous. People of non-African descent today carry somewhere between 1 and 4% Neanderthal DNA, embedded in their genomes like a message from a distant encounter. Similar evidence shows interbreeding with Denisovans, particularly visible in the genomes of modern Melanesian and Australian Aboriginal peoples. There was also, almost certainly, cultural exchange. The archaeological sites in the Middle East and Europe show mixed tool technologies during the period of overlap, Neanderthal techniques appearing in modern human contexts, and vice versa. Knowledge was being transmitted somehow, traded perhaps, at encounters between groups at resource-rich locations. But there was almost certainly also competition. Same caves, same hunting territories, same water sources, same herds of prey animals. And modern humans seem to have had certain advantages, not in raw intelligence necessarily, but in the structure of their social networks. Modern human bands appear to have maintained connections across larger distances, trading with groups much farther away, sharing innovations more rapidly, maintaining cultural practices across geographic ranges that would have been impossible for smaller, more isolated Neanderthal communities. When one group can share a new hunting technique across a network of 10,000 people spread across a continent, and the other group can only share it within a band of 50, the mathematics of innovation accumulation favor the first group overwhelmingly. Even small advantages in tool efficiency or hunting strategy, when they spread and compound across large interconnected networks, can translate into enormous differences in survival rates over the span of a few thousand years. The Neanderthals didn't die in a dramatic confrontation. They faded, outcompeted, their populations dwindling in their last refuges along the southern coasts of Europe, their genetic legacy preserved, in small measure, in the bodies of the people who replaced them. By around 40,000 years ago, they were gone. And your ancestors, now spread across 3 continents, now the only human species remaining on Earth, entered a period that archaeologists call the Upper Paleolithic, and which represents, in retrospect, the beginning of the end of the long silence. Something was shifting. The explosion was gathering itself. How farming changed everything, and what it cost us. The last ice age peaked around 20,000 years ago. Continental ice sheets a mile thick covered much of northern Europe and North America. Sea levels were hundreds of feet lower than today, exposing land bridges that have long since disappeared. The world was cold, dry, and, in many regions, extraordinarily harsh. And then, slowly at first, and then with gathering speed, the climate changed. Temperatures rose, ice sheets retreated, sea levels climbed, drowning the coastal plains that had served as migratory highways for tens of thousands of years. Forests advanced northward into territories that had been tundra and steppe. Grasslands rearranged themselves. Rain belts shifted. For the human populations that had spent tens of thousands of years adapting to Ice Age conditions, this transformation was both a disruption and an opportunity. Old hunting grounds vanished under rising seas or dense woodland, but in some valleys, some river deltas, some places where the new climate created conditions of unusual abundance, something new was beginning to happen. People were starting, very tentatively, to stay in one place, not because they'd suddenly decided that permanent settlement was superior to nomadic life, but because, in these specific locations, the resources were concentrated enough that moving constantly made less sense than making the most of what was already available. The Fertile Crescent, that arc of territory stretching from the Nile Valley through the Levant and into the floodplains of the Tigris and Euphrates rivers, became one of the most important of these places. Here, certain wild grasses grew in dense stands, their seeds nutritious and calorie-rich. Here, the ancestors of modern sheep, goats, cattle, and pigs roamed in herds large enough to sustain human predation over long periods. And then, around 12,900 years ago, just as things seemed to be settling into something more comfortable, the climate lurched backward. The Younger Dryas. For reasons that are still not completely understood, possibly related to the massive influx of fresh meltwater from retreating glaciers disrupting ocean circulation patterns. The northern hemisphere underwent a rapid, dramatic cooling event. Temperatures in the Levant dropped sharply. Rainfall became unreliable. The wild grains that communities had begun to depend on thinned out or failed. Here's what makes the Younger Dryas so important in human history. It hit communities that had already grown large enough and sedentary enough that the classic response to hardship, move somewhere better, was no longer straightforward. The valleys and uplands were already occupied. Extended families had grown into proto-villages. There wasn't endless open space to expand into. And so, backed into a corner by climate and demography simultaneously, some communities tried something different. Instead of wandering to where the plants were, they began, very tentatively, bringing the plants to them. The first steps were probably invisible, even to the people taking them. You gather wild seeds, as your people have always done. But this season, you spill some near camp. You notice that grain sprouts more thickly in the disturbed soil around your hearths, in the nutrient-rich midden heaps where organic waste accumulates. You begin, perhaps, to press seeds deliberately into soft ground near your water source. Small acts, barely conscious choices. But over generations, those small acts compound into something revolutionary. Because when you consistently harvest grain from particular plants, the ones that hold their seeds a little longer, making them easier to collect before they scatter, you're unknowingly selecting for a genetic trait. The plants that don't shatter their seeds get harvested and replanted. Their offspring inherit the trait. Slowly, the plants you're working with evolve, becoming less able to disperse themselves without human intervention, and therefore more dependent on humans to survive. And the humans, who now depend on these plants, become correspondingly more dependent on staying near the places where the plants grow. This is domestication, and it happened independently across multiple continents in the centuries and millennia following the end of the Ice Age. In the Fertile Crescent, wheat, barley, lentils, and peas. In China, along the Yellow and Yangtze River valleys, rice and millet. In Mesoamerica, the remarkable transformation of a wild grass called teosinte into maize, a process so dramatic that for a long time, botanists couldn't identify the wild ancestor of corn at all. In New Guinea, taro, bananas, and yams. In Africa, sorghum and pearl millet. None of these revolutions happened because of a grand plan. None of them started with someone deciding to invent agriculture. They were, each of them, the accumulated consequence of thousands of small decisions made by people trying to do what people have always done: get through this season with enough food to make it to the next one. But the consequences were profound. And here's where it gets complicated. Not entirely positive. When you look at the skeletal remains of early agricultural communities in the Fertile Crescent and compare them to the hunter-gatherer populations that preceded them, what you find is disturbing. The farmers are shorter. Their teeth show more cavities and enamel defects, signatures of the high-carbohydrate, nutritionally narrower diet that agriculture produces. Their bones show the evidence of repetitive strain, spines compressed by constant bending, joints worn by the endless grinding, hauling, and hoeing that farming requires. As signs of infectious disease increase as larger groups of people and animals live in closer proximity, sharing pathogens with terrible efficiency. The workday lengthens. A successful hunter-gatherer might meet their caloric needs in 3 or 4 hours of focused effort. A farmer's tasks are endless: breaking ground, planting, weeding, managing irrigation, watching for pests, harvesting, threshing, winnowing, grinding, storing, and always caring for animals, repairing structures, maintaining tools. The agricultural life at the individual level is harder work for worse health outcomes than the nomadic life it replaced. So why did it spread? The answer lies in what economists call a coordination trap, a situation where what's good for the group diverges dramatically from what's good for the individual. Agriculture is, from the perspective of population dynamics, an extraordinarily effective strategy. A farming community can support many more people per square mile than a hunter-gatherer community in the same landscape. More calories per acre means more babies surviving infancy, which means more people in the next generation, which means more labor available to farm more acres, which means more food, which means more people. The feedback loop is self-reinforcing and relentless. But here's the trap. Once you've grown a population to several hundred or several thousand people, depending on those crops, going back becomes nearly impossible. The landscape has been transformed. Wild game has been hunted to low density. Wild plant communities have been disrupted. The foraging capacity of the surrounding land has been depleted precisely because it's been converted to farmland. The genie is out of the bottle. Agriculture, once established, is effectively irreversible, not through design or philosophy, but through pure, merciless demographic logic. It was, in a very real sense, a trap that came with enormous benefits for the species and considerable costs for many of the individual humans who lived inside it. But inside that trap, something new was becoming possible. Surplus. And surplus, it turns out, changes everything. Because once there is more food than immediate need requires, choices emerge about who controls it, who decides when to open the grain bins, how to distribute it in a lean year. These questions create space for new social roles. Keepers of the granaries, specialists in pottery, in weaving, in ritual, and specialists over time accumulate not just skills, but advantages. Property emerges, inheritance follows. Inequality, once limited by the perishability of resources, since meat spoils and you can't hoard it forever, becomes structural and durable. A family with a larger granary and a larger flock passes those advantages to their children, who pass them to theirs. And from structural inequality, something new emerges. The need to manage it, to legitimize it. You need stories about why things are the way they are. You need institutions. You need authority structures. You need, eventually, something that begins to look like a state. But before the state comes something else. Something that, when archaeologists found the evidence of it, completely upended the conventional story of how civilization began. A set of massive stone pillars, carved with extraordinary artistry, arranged in circles on a hilltop in what is now southeastern Turkey. Built not by farmers, not by people with surplus and specialized labor and complex social hierarchy. Built by hunter-gatherers, 11,600 years ago. And it suggests that the relationship between religion, community, and agriculture is almost exactly the reverse of what we thought it was. Göbekli Tepe sits on a ridge in southeastern Anatolia, overlooking the plains of what is now northern Syria. When it was built, approximately 11,600 years ago, there was no agriculture in the surrounding region. No farms, no settled villages, no surplus grain stored in centralized granaries. The people who built this extraordinary structure were foragers, hunter-gatherers who moved with the seasons, who had no complex political hierarchy. This completely inverts the model of how civilization was supposed to work. The old story: first agriculture produces surplus. Surplus allows specialization. Specialization creates hierarchy. Hierarchy builds monuments and temples. Religion as the product of settled, organized societies. The new story, which Göbekli Tepe seems to be telling, large-scale communal ritual may have preceded agriculture. May, in fact, have helped drive it. Because think about what it would take to feed hundreds of people gathered at a place like Göbekli Tepe for weeks or months of construction. You'd need reliable, storable food in quantities that nomadic foraging can't easily provide. You'd need, in other words, exactly the kind of intensive plant and animal management that eventually becomes domestication. Perhaps agriculture didn't produce religion. Perhaps the desire for religion, for shared ritual, for communal monuments, for the kind of large-scale social coherence that only shared symbolic systems can provide, helped produce agriculture. We built temples, and the need to feed the builders drove us to farm. How cities and symbols changed the nature of memory itself. Whatever the precise sequence of religion and agriculture, the consequences of settled life accumulated steadily over the following millennia. Villages appeared, then grew. Storage became more sophisticated. Social roles differentiated as surplus allowed some people to specialize in activities beyond food production. Trade networks extended across hundreds of miles. By around 3,500 BCE, in the broad alluvial plains between the Tigris and Euphrates rivers, in a landscape so flat and featureless that it offered no natural resources except the extraordinary fertility of its river-deposited soils, something appeared that had never existed before on Earth. A city, not a large village, not a dense settlement. A city, a concentration of tens of thousands of people, living in organized neighborhoods with distinct districts for different kinds of production, with massive ceremonial complexes rising above the plain on terraced platforms of mud brick, with sophisticated canal systems for irrigation and transportation, with a bureaucracy capable of tracking the movement of thousands of tons of grain, wool, and other commodities. Uruk. At its peak, Uruk may have been home to 50,000 or even 80,000 people. In a world where most human settlements numbered in the hundreds, this was almost incomprehensible. It was a scale of human organization that exceeded anything the social instincts refined over hundreds of thousands of years of small group living had been designed for. In a small band, you know everyone. You know their histories, their strengths and weaknesses, their family relationships, their social obligations. Social coordination happens through direct relationship. In Uruk, most of the people you encountered in a day's work were strangers. Your transactions, your obligations, your claims None of these could be managed through the informal mechanisms of reputation and memory that worked perfectly well in a band of 50. You needed something else. You needed, in a word, administration. And administration, at sufficient scale, generates one of the most important inventions in human history: writing. It didn't arrive as a sudden inspiration. It condensed slowly and practically out of centuries of experimentation with accounting and tallying. The earliest proto-writing in Mesopotamia wasn't poetry or philosophy or even records of historical events. It was receipts, inventories, lists of goods delivered to the temple storehouses, rations allocated to workers, quantities of grain moved between districts, practical, prosaic, utterly unmysterious in its immediate purpose. The technology evolved in stages. Early on, accountants used small clay tokens of different shapes, cones, spheres, discs, to represent quantities of different commodities. To record and seal a transaction, they would gather the relevant tokens and press them into the surface of a ball of clay, then seal it. The sealed ball, marked with the identities of the parties involved, became a kind of contract. But as Uruk grew and transactions multiplied, this system became unwieldy. Someone had the insight that instead of pressing three-dimensional tokens into clay, you could press the shape of those tokens, impressions that represented the objects rather than embodying them. The tokens flattened into marks, the clay ball flattened into a tablet. And once you're making marks on a flat surface to represent things, the logic of abstraction begins to operate on its own. The marks simplify. They become more stylized, less obviously pictorial, standardized enough that anyone trained in the system can read them. Eventually, and this is the crucial step, they begin to represent not just objects and quantities, but sounds. The system breaks free from one-to-one correspondence with physical things and becomes capable of encoding language itself. This is cuneiform, wedge-shaped marks pressed into clay with a cut reed, and it represents one of the most important cognitive expansions in the history of our species, because for the first time, information could be made external and durable in a systematic way, not just in memory, not in oral tradition, fragile and dependent on the continued survival of the people who carry it, not in paintings on cave walls whose meanings must be actively transmitted to remain legible, but in a system that any trained reader could decode. A scribe in Uruk could write a document that a scribe in a city 100 miles away, who had never met them, could read. Instructions for distributing grain could be composed today and followed next year, without anyone having to remember them. An agreement about a land boundary could be recorded and consulted decades later, when the original parties were dead and their children were disputing the inheritance. A hymn to a god could be copied and recopied across centuries, its words preserved intact long after the civilization that originally composed it had fallen. Writing turns time into something you can stack, reference, and re-enter at will. It transforms memory from an individual biological function into a collective, permanent social resource. Knowledge, which for hundreds of thousands of years lived only in living minds and died with them, gained a new home in clay and papyrus and parchment, and it was not only in Mesopotamia. Across the connected and disconnected worlds of the ancient Near East, similar pressures were producing similar solutions. along the Nile. As small kingdoms coalesced into a single state under the rule of the pharaohs, Egyptian hieroglyphs emerged, blending phonetic and logographic elements with a visual sophistication that makes clear writing was already understood as something more than mere accounting. In the Indus Valley, cities like Mohenjo-daro and Harappa developed their own script, one we still cannot read, whose underlying language we don't know, but which clearly encoded a sophisticated system of identity and record-keeping. In China, along the Yellow River, the earliest known Chinese writing appears on oracle bones, questions posed to ancestral spirits, carved into turtle shells and ox scapulae, heated until they cracked, and then read by trained interpreters. Different materials, different aesthetic traditions, different relationships between picture and sound. But the same underlying pressure. Once you have dense populations, stored surplus, institutions that outlive individuals, and decisions whose consequences stretch over decades and generations, you need tools to stabilize information. You need writing. And once you have writing, the acceleration begins in earnest, because now innovations can be recorded and distributed. Now laws can be written down and compared across jurisdictions. Now the observations of one generation's astronomers can be the foundation for the next generation's mathematics. Now stories can travel across distances that no living person could traverse and survive across spans of time that no individual memory could bridge. The long silence accumulated across 250,000 years of brains that could think but couldn't quite accumulate fast enough was finally ending. And it was ending for a very specific reason. We had built systems that could hold knowledge outside of individual human minds and share it across the vast interconnected networks we were building. The ratchet would never slip backward again, and the gears were about to begin turning very, very fast. From the Axial Age to the Digital Dawn, the compounding of everything. By around the year 600 BCE, something strange and probably unprecedented was happening across the ancient world. In China, a minor official named Kongzi, who would come to be known in the West as Confucius, was wandering from court to court, arguing that the way to fix society's problems was not better laws or stronger armies, but moral cultivation. That rulers who governed by virtue rather than fear would produce societies worth living in. That the relationships between people, parent and child, ruler and subject, friend and friend, were the fundamental units of civilization, and that getting those relationships right was the most important work a person could do. In northern India, a prince named Siddhartha Gautama, disturbed by the suffering he witnessed in the world outside his sheltered palace life, left everything he knew to search for the cause of that suffering. He would eventually conclude that suffering arises from craving, that craving can be understood and released, and that there is a path, ethical, meditative, disciplined, through which a person can achieve liberation. His insights would become Buddhism, which would spread along trade routes across Asia for the next 2 millennia. In the Greek city-states of the Aegean coast and mainland, a tradition of radical questioning was emerging that would eventually be called philosophy. Socrates wandered the streets of Athens, asking craftsmen and politicians and young men Why they believed what they believed, exposing the gaps between their assumptions and their conclusions. Plato wrote dialogues that explored the nature of reality, truth, beauty, and justice with a rigor and depth that still generates scholarly debates 2,400 years later. Aristotle, perhaps history's most systematically curious mind, turned his attention to everything: logic, biology, ethics, politics, physics, aesthetics, rhetoric, treating each domain as something that could be understood through careful observation and reasoned analysis. This cluster of intellectual developments, happening across the Eurasian world in roughly the same few centuries, is what the philosopher Karl Jaspers called the Axial Age. The axis, the pivot point around which something fundamental in human civilization turned. Why did it happen? No one can say with certainty, but the pattern suggests some important contributors. Urbanization, which concentrates people and problems in ways that force more abstract thinking about social organization. Long-distance trade, which brings people into contact with radically different ways of living and governing, and makes it much harder to take your own way of doing things as the only possible way. Writing and the early spread of literacy, which make it possible to engage with ideas across time, to argue with dead thinkers, to build systematically on previous foundations. Under these conditions, religion and philosophy began doing something new, providing frameworks for moral community that could extend across diverse, multicultural populations. You don't need to know someone personally or share their ethnicity or local customs to share a commitment to Buddhist ethics or Confucian virtue or Stoic reason. These systems of thought are, in a sense, social technologies for operating at scale, for building the kind of trust and cooperation that cities and empires require, without depending on the personal relationships that work only in small groups. The foundations were being laid for the structure that would eventually hold the entire edifice of modern civilization. But the acceleration was still gradual. For all the brilliance of the Axial Age, the pace of material change remained slow by modern standards. The basic conditions of most people's lives, agricultural, local, constrained by the physical limits of human and animal muscle power, changed little from one century to the next. What transformed the speed of everything was a specific cascade of technologies beginning in the mid-15th century. In a goldsmith's workshop in a mid-sized German city, Johannes Gutenberg didn't invent printing. Movable type had existed in China for centuries, but Gutenberg combined several existing technologies: movable metal type, oil-based ink, a modified screw press, in a way that was uniquely suited to the alphabetic writing of European languages and uniquely suited to the economic and intellectual environment of late medieval Europe, where a growing merchant class was hungry for information and a church whose authority depended on controlling access to Scripture was about to encounter a technology that made that control impossible to maintain. The printing press was a second writing revolution. If writing transformed memory from a personal to a collective resource, printing transformed it again from a collective resource that required specialized copyists and was therefore expensive, slow, and limited in distribution to something that could propagate at a speed that outpaced any mechanism of control. A text could be reproduced in hundreds of identical copies in the time it would have taken a scribe to produce one. The effects were immediate and catastrophic for the old order, in the most generative possible sense of catastrophic. Martin Luther's theological complaints, which in an earlier era might have circulated in a few handwritten copies among scholars before being suppressed, were printed within weeks of their composition and distributed across the German lands in months. The Protestant Reformation demonstrated what happens when the technology for scaling ideas outpaces the institutions trying to control them. 60 years later, Nicholas Copernicus published his argument that the Earth moves around the Sun. The book was dense, mathematical, and initially read primarily by specialists. But it was printed. It persisted. It traveled to astronomers who could check its mathematics. And a century later, when Galileo's telescope provided observational evidence that the old Earth-centered model couldn't explain, the printed copies of Copernicus were there, waiting to be integrated into a new synthesis. The scientific revolution, the transformation of how Europeans understood and investigated the natural world, was not the work of isolated geniuses. It was the work of a network: observers, experimenters, theorists and mathematicians who could read each other's work, respond to each other's arguments, and build an increasingly precise and powerful description of how the physical world operates. Newton famously said he stood on the shoulders of giants. He could do so because printing had made those giants' work accessible across a century and across a continent. And once you have a reliable method for discovering how the natural world works, and a technology for distributing that knowledge to anyone who can read, the next revolution becomes almost inevitable. The Industrial Revolution was, at its core, a transformation in humanity's relationship to energy. For all of human history, all 250,000 years of it, the energy available for human projects was limited by the productivity of living biological systems. The food people could eat, the plants and animals that could be harvested, the water that could be diverted, the wind that could be captured in sails and windmills. Coal had been burned for centuries, but in the 18th century, inventors began to harness it in a qualitatively new way. Steam engines, initially crude, inefficient devices for pumping water from flooded mines, were gradually improved to the point where they could do mechanical work of any kind. And then someone connected them to spinning machines, to looms, to railway locomotives, to steel mills. Now, for the first time, the energy available for human projects was not limited by the productivity of living systems. The consequences unfolded over decades and then centuries. Factories, railroads, steamships, telegraphs, electric lights, automobiles, airplanes, nuclear power, computers, the internet. Each development building on the previous ones, each expanding the scale of what was possible, each feeding back into a system of knowledge production and distribution that kept accelerating. The population curve, which had been rising slowly for millennia, bent sharply upward. 1 billion people by 1800, 2 billion by 1928, 4 billion by 1975, 8 billion today. This was not primarily because people were having more children. It was because more children were surviving, vaccinated against diseases that had killed millions, fed by agricultural systems made enormously more productive by synthetic fertilizers and mechanized farming, treated for injuries and illnesses that had previously been death sentences, drinking water that no longer carried cholera. And then, in the mid-20th century, a new layer of acceleration was added. Electronic computing began as a tool for specific, high-stakes calculations, code breaking, ballistics, census processing. Room-sized machines of vacuum tubes and punch cards produced results that would have taken human calculators months or years. Transistors replaced vacuum tubes and made the machines smaller, cheaper, faster. Integrated circuits made them smaller still. And then, in the 1970s and 1980s, personal computers appeared on desks, and the democratization of computational power began. The digital revolution is a third communication transformation, following the invention of writing and the printing press. If writing let memories escape the brain and persist across time, and printing let them multiply and distribute across space, digital networks let them flow, mutate, recombine, and propagate at a pace that has no precedent in human history. More information is generated, transmitted, and stored in a single day today than existed in total throughout the entire span from the invention of writing to the Industrial Revolution. A person with a smartphone in their pocket has access to more text, more recorded knowledge, more images and data than the greatest library of the ancient world contained. A scientist can share a discovery with thousands of colleagues around the globe within seconds of making it. The conversation that began with ochre markings on cave walls and cuneiform tablets on clay has become a global, real-time exchange involving billions of participants simultaneously. We are still in the very early stages of understanding what this means for human organization, for the pace of innovation, and for the distribution of power, for the structure of knowledge itself. The tools are changing faster than our institutions, faster than our moral frameworks, faster than our collective wisdom about how to use them well. The curve of change, which was essentially flat for 240,000 years, bent upward 10,000 years ago, steepened with writing and the first cities, accelerated with the printing press, bent dramatically with industrialization, and has been approaching vertical for the past 50 years. We are living at the tip of that curve, and the question of where it goes next is the most important question our species has ever faced. What we do with the power we didn't ask for. Let's do one more thought experiment. Imagine one of those survivors, one of the estimated 3,000 to 10,000 human beings who made it through the Toba Bottleneck 74,000 years ago, who endured the volcanic winter, watched populations collapse around them, clung to whatever refuges offered enough food and water to keep breathing, and came out the other side. They were tough, experienced. They understood the natural world with an intimacy that most modern people couldn't begin to approach. They could read the sky, track animals across stone, identify dozens of plant species by smell alone, navigate by stars across landscapes without any visible landmarks. They were, in every meaningful sense, experts in surviving on this planet. Now, imagine bringing that person forward in time. showing them our world. What would they see? Cities glowing like constellations turned upside down, visible from orbit. Great silver birds crossing oceans in a matter of hours. Machines that can speak and reason and remember more than any elder who ever lived. Wild grasses, the same kinds of plants their ancestors began to tend 10,000 years ago, transformed into mountains of grain sufficient to feed 8 billion people. Water running at the turn of a handle. Night abolished at the flick of a switch. Moving images of people and places on the other side of the world, transmitted through the air and displayed on glass rectangles thin enough to slip into a pocket. They might be awed. They might be terrified. They might struggle to understand what they were seeing at a level that we would struggle to understand looking at a world we'd never seen. But here's the thing. If you watched them carefully enough, eventually you would see something that looked familiar. They would gather in groups. They would talk. They would argue and laugh and worry about their children. They would scan the horizon, metaphorically, at least, for danger. They would tell each other stories. They would form bonds of trust and obligation with some people, and suspicion or hostility toward others. They would seek meaning. They would wonder why they were here and what would happen when they died. Under the satellites and skyscrapers and fiber optic cables, we are still doing what we have always done. The fundamental human things: connection, curiosity, meaning-making, love, fear, wonder, haven't changed since those survivors emerged from the volcanic winter 74,000 years ago. What has changed, with extraordinary and still accelerating speed, is the scale and the tools. We now have the tools to end hunger, and food insecurity still affects hundreds of millions of people. We have the tools to communicate across every language barrier on Earth in real time, and we use them, in part, to spread misinformation at a speed and scale that no previous civilization would have considered possible. We have the tools to understand our own biology at the level of individual molecules, and we are still struggling to distribute that understanding equitably. We have the tools to measure and model the climate of the entire planet, and we are watching, in real time, the consequences of 200 years of burning the stored sunlight of ancient forests. The question isn't whether we have the capability. We demonstrably do. The question is whether the wisdom to use the capability well is accumulating fast enough to keep pace with the capability itself. And this is not a new problem. It is, in a deep sense, the oldest problem our species has ever faced, just operating at unprecedented scale. Every society that has ever achieved a significant increase in power has faced the same challenge. How do you build the social, moral, and institutional frameworks that allow that power to be used in ways that benefit the group rather than destroy it? This is what the Axial Age was grappling with. The philosophers and prophets and teachers trying to develop ethical frameworks adequate to the scale of the cities and empires their societies were building. This is what the Enlightenment was about, applying reason not just to understanding the physical world, but to the organization of human society. We haven't always gotten it right. The history of the last few centuries is full of examples of what happens when power races ahead of wisdom. The industrial pollution that poisoned cities and rivers before we understood the consequences. the weapons that multiplied the destructive power of human conflict beyond anything previously imaginable, the economic systems that created unprecedented wealth and also unprecedented new forms of poverty and dispossession. But we're also still here, still building, still arguing about what we owe each other, still creating art that reaches across the barriers of language and culture, still doing science that expands the frontiers of what it's possible to know, still teaching children to read, which is still one of the most revolutionary acts a person can perform, opening a mind to the accumulated thought of all the humans who came before. The long silence of our history, those 240,000 years of almost imperceptible change, wasn't silence in any absolute sense. It was accumulation, slow, fragile, frequently lost and rediscovered, but fundamentally oriented toward something, toward the ability to pass knowledge forward, toward the ability to coordinate at larger and larger scales, toward the tools that would eventually allow a species that nearly went extinct 74,000 years ago to write symphonies and build telescopes and feed billions of people, and, for the first time in the history of life on this planet, look back at their own home from the blackness of space. We are a young species in the universe. We have existed in our current form for less than 3/10,000ths of the age of the Earth. The history of our civilization, everything from the first city to this moment, represents less than 5% of the time we've been here. We are at the very beginning of whatever we might become. And the question that the Bottleneck survivors might want to ask us, if they could see what we've built and what we're doing with it, is the same question every parent has ever asked every child who gained some new power. What will you do with this? Not in a scolding sense, not with an expectation of perfection, but with the understanding that the answer to that question is the most important thing about us right now. Will we use the extraordinary tools we've built, the tools for understanding our world, for communicating across distances and cultures, for feeding and healing and educating billions of people, to make our civilization more stable, more just, more resilient, more generous toward the other species that have shared this planet with us for as long as our lineage has existed? Will we leave the climate, the same narrow band of temperature and rainfall that nurtured every chapter of human history, from the first ochre markings in Blombos Cave to the first steps on the moon, within the bounds that make human civilization viable? Or will we turn our extraordinary tools against each other and against the planet that made us, and write an ending that future intelligences, whatever form they might take, will look back on as the greatest waste in the history of a universe that is, as far as we know, extraordinarily sparing with beings capable of asking these questions at all? We cannot know the answer. We are living inside the question. But here is what we can say. We are the descendants of people who survived everything, who came through volcanic winters and ice ages and near extinction, and the deaths of entire species they lived alongside, who learned to plant seeds and build walls and write words and ask why, who have been reaching generation after generation toward something they couldn't quite articulate but couldn't stop moving toward. We carry their genes, we carry their questions, we carry the entire weight of their long effort toward this moment, this extraordinary, dangerous, possibility-saturated moment, in our language, our institutions, our art, our science, our stubborn human habit of imagining that tomorrow might be better than today. The story isn't finished. It has barely begun. And you, wherever you are as you hear these words, in whatever room or city or country, whatever moment of your own brief story you're inhabiting right now, you are one of the voices it will be told in. From perhaps 3,000 frightened survivors huddled in scattered pockets of Africa, to 8 billion humans wrapping a web of light and radio around an entire planet, sending machines past the edge of the solar system, listening to whispers from the first galaxies. Same lineage, same fused chromosome, same hungry, curious brain. Under the satellites and skyscrapers and the glow of a billion screens, we are still doing very old things. We gather in groups, we share stories, we gossip and argue and fall in love. We worry about our children. We scan the horizon for danger. We dream about tomorrow. We still depend on the same thin layer of air, the same soils, the same cycle of rain and sunlight that sustained those small bands during the long crisis, the crisis that almost ended everything, and instead forged something that nothing in the previous history of this planet had ever quite been before. A species that doesn't just live in the world, a species that wonders about it. The silence, it seems, has ended. What we do with the noise is up to us.